Math 98 Exam Review, Spring 2015, Part 7. You will need to be able to solve systems of equations like these shown. To solve a system of equations using elimination, you need to make the coefficients of at least one set of the variables, x or y, opposite values. If we multiply the first equation by -3, this x will become -3x and be the opposite of 3x. -3 times x is -3x. -3 times 2y is -6y. -3 times 10 is -30. Now we'll add the two equations together, in which case you'll notice that both the x and the y's add to 0, and -30 and 30 add to 0. When all of the variables are eliminated and the resulting equation is a true statement, 0 equals 0, these original lines are the same line, only in slightly different form. And that means that there are an infinite number of ordered pairs. Any ordered pair that works in the first one will work in the second one. So the solution is written this way: any ordered pair xy such that it works in x plus 2y equals 10. You may use either equation and in any form. So I could solve this for y as well. As long as it's one of these original equations in any form, this is the way we write our solution. Now the second example. In order to make the x's have opposite coefficients, I need to multiply the bottom equation by -2. First equation stays the same. Bottom equation becomes -2 times x, -2 times 6y, which is -12y, and -2 times -22, which is +44. Now we can add these together and eliminate the x's. A -1y and a -12y is -13y. Divide both sides by -13, y is -4. We could, at this point, use elimination again and try to eliminate the y variables by multiplying the top one by 6. However, it's not necessary. Once we find one of the values, we can use substitution. Take the original equation, either one, and substitute the -4 in for y. So I took the first equation. I have 2x minus y equals 8. Instead of y, I put in a -4. Minus a negative becomes add the opposite, +4. Subtract 4 from both sides. Since the 4 minus 4 is 0, you're left with 2x and 4. Divide both sides by 2, so x has to be 2. So we've found an ordered pair that is the solution to this system. However, before we conclude that, let's make sure that the ordered pair works in both equations. So here I've taken the original first equation and substituted the point 2 for x, or the value 2 for x, and the -4 for y. 2 times 2 is 4. Subtract -4 is going to be add 4, and that's going to give me an 8, and that's going to check. So it works in the first equation. Now for the second equation. Substitute 2 for the x and -4 for the y. Becomes 2 plus 6 times -4, which is 2 plus -24, which is -22. It checks in the second equation. Since the point works in both equations, this is the system of the equation system, and it's the only solution to this system. So we write the ordered pair 2, -4 as the solution to the system. No other points will work. And for our third system, we'll use the same method of elimination. We will multiply the first equation by -6 in order to make these a -12 and a +12. We get -12x plus -18y equals -60. Then we get 12x plus 18y equals 30. When we combine the two equations, negative 12x and 12x is 0, negative 18y and 18y is 0, and on the right-hand side we get negative 30 because negative 60 plus 30 is negative 30. This is a false statement. That means there is no solution for this original system because these are parallel lines.